So what we want to do is we want to be able to prove triangles congruent. We've been doing some of that stuff. We've been dealing with side, angle, side, all of those postulates and theorems that allow us to prove two triangles congruent. Today, we're going to talk about one more, and this will be the last one that allows us to prove triangles congruent. Okay, but it only works in right triangles. Okay, so before we even get to the theorem, there's a couple foundational things we got to talk about. One of them is kind of more like a technical thing in regards to us writing proofs. Not 100% sure on what the in-course exam is going to ask in regards to what proof they ask you to do. But in the event they ask you to do something with the hypotenuse leg theorem, which is what we're going to learn today, I would think that's probably a good idea for you to make sure that you tell the person that's grading your paper, grading your test, that inside your proof you have right triangles somewhere. Okay? Think about if you're ever in a situation and you're doing an assignment, you're doing a test or whatever, and you know that there's something that you could add into it, but you're not sure if it's required, but you're worried that if you don't put it in, you're going to get some points marked off. What would you probably do in that case? Put it in, right? Okay. So kind of view every time you take an important exam, not just this class, but other classes, if you have doubt of whether it's needed or not, put it in. Okay. Because it's going to be, as long as it's true information. Okay. The more expressive, the more explicit you are with your ideas and your statements and a proof, obviously the more accurate your proof is going to be, and the less chances of the reader marking something that was necessary, or marking something off that was necessary. Yes?
When does Thanksgiving start?
Next Wednesday. Tuesday, the last day.
Well, how does it have an optional review within the next day?
What do you mean?
Optional review will be posted within the next day or so.
Since today or tomorrow, our first one, you can work on it over the weekend, and work on it Monday, and then we do Tuesday.
Oh, never mind.
What about people assigned on the tomorrow?
You're here tomorrow?
Yeah.
Okay. We're just gonna we'll be probably going over homework tomorrow. During class. But there'll be the video online and all that kind of stuff. So before going back to the math, before we get to using this theorem that we're going to learn here, which is really easy to learn, the first thing we have to do inside our proof is just say that the two triangles I'm working with are right triangles. Now, how do you identify something as a right triangle? What's the key identifier for a right triangle? 90 degrees. You're going to have a right angle in there, right? Okay. So we're going to say somewhere in our proof that we have right angles, and then after that we'll say, well, that means that we got right triangles. Okay. Is that okay, everyone? Okay, so that's what that one's saying. The next slide says we got to have some vocabulary about right triangles that should be kind of common sense at this point, I would think. The hypotenuse, you guys know the hypotenuse is across from the what? The biggest angle, okay, across from the right angle, okay? Hypotenuse got to be the longest side. We've talked about that before in other grade levels, but in a right triangle, the largest angle is always the right angle, right? And then in any triangle, across from the largest angle needs to be the largest side, right? So if 90 is always going to be the maximum in that type of triangle, then across from it, the hypotenuse is always going to be the maximum size, so the largest side, okay? The other two sides, okay, that are not the hypotenuse, we refer to as legs, okay? Later on, we will concentrate on what those legs are, and maybe in a different aspect. We like to call those altitudes, and we'll investigate right triangles based off of those legs, and not so much maybe the hypotenuse. But right now, we need to know those definitions. Okay, hypotenuse across from a 90-degree angle. Everything else is a leg. Pretty easy. Okay. That gets us to be able to talk about this theorem. Okay, so hypotenuse leg theorem. Okay, shortened as HL. Basically, what it says is it's the same kind of breakdown as any of the other postulates theorems we talked about so far for congruency. Look at the name H and L, so it must mean I need a hypotenuse congruent to a hypotenuse, and then I need a leg congruent to a leg. And that is enough then to say the two triangles are congruent. Which this is a convenience, I think this is one of the theorem, or is the theorem that's easier to use than any other ones. Because in the other ones we had to show 3 parts congruent to 3 parts, right? And so here we had to show just 2 parts congruent to 2 parts. In the other ones, then maybe they gave us enough information in the given to find maybe 1 congruency, and then we had to go through and do the work using postulates and theorems and definitions to find 2 other congruencies. Here, most of the time, they'll give you 1 congruency, and all you got to do is find 1 more. Okay? So it's actually the proofs that deal with hypotenuse leg are usually a little bit easier than the ones with side, 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 angle, side, and that kind of stuff. But once you prove the triangle is congruent, everything that we've talked about with the other postulates and theorems, using CP, okay, all of those practices can be used after we use hypotenuse leg. Okay, so it's just another one of our options for showing 2 triangles congruent, but in this case, just 2 right triangles. So that would be an example of hypotenuse leg. Okay, obviously hypotenuse congruent to hypotenuse, and then 1 leg congruent to the other leg. So right now, as we go through and list the things that we talked about, we got side, 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 angle, side, angle, and angle, angle, side, right? Those work for any type of triangle. Whether they are right triangles, they might be obtuse, they might be acute, they might be isosceles, whatever. Those work for all types of triangles. Okay, we're trying to deal with congruencies. Hypotenuse leg only works with
Right triangle.
right triangles. Only works with triangles that have hypotenuses, right? Okay. So that's something to think about as we go through this. Meaning, okay, if side, side, side works for any type of triangle, you could potentially use side, side, side to prove 2 right triangles, right? Congruent?
Yes.
So you could use one of those top 4 to prove the same thing that you would prove using hypotenuse leg. Okay? So keep that in mind as we go through. We'll actually see one today. Do a quick proof, and it will be able to be proven using hypotenuse leg or angle side. Okay, so that's something to kind of think about as we go through. Hopefully, we realize the more we learn, the more concepts that we relate to one another, the more definitions, theorems, that kind of stuff. It starts to open doors to proving things in more than one way. And that's the nice thing about math, but at some point, people dislike that because kind of maybe the uncertain approach that you could use. Okay, knowing that I can use 3 or 4 different ways, people get, maybe kind of confused. They don't know which one's the best or which one to choose. Okay, but hopefully throughout the course we'll be able to kind of fix that uncertainty. We good?
Yeah.
Okay. So I'm going to do a couple proofs here with you that are going to allow us to use hypotenuse leg. They're not extremely difficult. We just want to prove 2 triangles congruent, but walk through the necessary steps and kind of the important additional aspects of these types of proofs that we need to incorporate, not knowing how we're going to be graded on the end of course exam with it. Okay, and also maybe talk about some statements that you could make that may or may not be necessary for us to prove this. So first thing I want to do, I'm going to kind of cheat, and if you guys want to do this as well, I'm just going to write given for the first statement and the second statement, or sorry, first statement, first reason, and then you guys obviously know that this stuff here should be actually written there, right? Okay. Just to save a little bit of time, I don't want to do that. And if you want to write that down in your notes the same way, that's fine. But make sure you at least got the given written somewhere. Don't do that on the end of course exam. Okay, they will mark that wrong. as I go through there, okay, I got right angles, right? Okay? So if you have right angles, look at your picture. You're dealing with right angles that are in triangles, right? What can you call those triangles now? Not congruent yet. If I've got two triangles and they both have right angles in them, they have to be... Will there be right triangles? Okay. Once you identify right angles, okay, and your picture incorporates triangles, and those right angles are parts of those triangles, identify the triangles as being right triangles. Okay. Hopefully that's obvious. Hopefully it's an obvious statement. And that's where some people, some authors of questions, and maybe an author of the test might not necessarily need you to write that or want you to write that. Okay, but it's right, correct? It's true. All right. The reason I want you to write it is because it hopefully elicits a thought for you. Okay. I just stated I have right triangles. I have triangles in my picture. I'm trying to prove triangles congruent. So when I have right triangles, one of my main methods for proving them congruent is to use hypotenuse leg. So I'm trying to hopefully kind of get the ball rolling for you on what route you want to take to prove these things congruent. Okay, so we've got those things to be true. The next thing I want to do is look at my picture. Okay, look at my picture. What segment do you know exists in both those triangles? Careful. What segment? PR. PR should be congruent to PR, right? And that's your reflexive property. Make sure we're using, obviously I can't type it all the right way, but make sure we're using that right notation when we're writing this stuff in our statements. So that's the reflexive property. So when I draw that in my picture, okay, our given gave us SP congruent to RQ, right? What types of segment for the right triangles? What type of segment is SP? I'm looking at that right triangle. SP is a hypotenuse. What is RQ? Hypotenuse. Do you have a hypotenuse congruent to hypotenuse? Yeah. What is PR for both triangles? That's a leg, right? It's a side. Okay, and if it's a side, it's not a hypotenuse. It's got to be a leg. So you got a leg congruent to leg. So you got a hypotenuse leg here. So automatically then, we can say that these two triangles okay, we say triangle PRS is congruent to triangle RPQ. And our reason is because we have a hypotenuse congruent to a hypotenuse and a leg congruent to a leg. So we've gone through and shown how we can use hypotenuse leg to prove two triangles congruent. Now think about why that might be a little bit easier than anything else we've done so far. Every other congruency that we've dealt with so far, you needed three things congruent to three things, right? Look at our given. We have one congruency, and now we have two congruencies. That's all we need to show with hypotenuse leg. Two congruencies to be true, and that allows the triangles to be congruent. It's much nicer than having to use one of the other theorems. Okay? But it only works in right triangles. Is that something we can do? Now, if I wanted to go beyond that, I want to say like angle S is congruent to angle P. Why would angle S right here be congruent to angle? Angle S be congruent to angle Q. Say again? Okay, so what was that phrase in that allowed that? You're right. That's CP, okay? So we say angle S congruent to angle Q by CP, CTC if we need to. So after we've shown triangles congruent, we go back to all the other stuff that we've done already. Okay? Is that pretty easy? All right. Let's do one more. Again, going to kind of cheat with my given. All right, so what's the first vocabulary word in this picture that you see, or in this proof that you see here?
Bisects.
Bisects. So what's bisects mean to us?
Two congruent things.
Two congruent things, two congruent parts, right? Because they're segments, we're going to have two congruent segments, right? Which segments up there are going to be congruent? Careful. AC and CD, good. Okay. Definition of segment bisecting. Right, if we read it, it says BE bisects AD. Okay. Another way of saying bisects is cuts in half, right? If I say BE cuts in half AD, that means AD gets cut in half, right? Does BE get cut in half?
No.
No. Okay. People all the time have issues with this and saying, BE should be getting cut in half as well as AD. Okay. And my answer to them is always, you cut a sandwich in half. You have bisected the sandwich, right? Do you get cut in half once you do that? No. So sandwich doesn't bisect you, right?
No.
Okay. If I bisect the sandwich is the only thing getting cut in half, right? So BE bisects AD. AD is the only thing getting cut in half. Okay. What's the other vocabulary word there? Huh? If I read the given, what's the other vocabulary word? It's not written out. Perpendicular. Okay? So AB is perpendicular to BC. Don't even look at your picture. If you've got two lines intersecting, one of them's AB and the other one's BC, at what point do they have to be intersected? If you look at just that phrase, AB perpendicular to BC, right?
B.
They have to intersect at B, right?
Yes.
So that tells you if they're perpendicular and they intersect at B, B has to be a no?
Right angle.
Right angle. Angle B is a right angle. Now, look at the next vocabulary word. It says DE is perpendicular to EC. Where do they have to meet?
E.
E. Okay, they share that point E. Okay, so angle B and angle E are right angles. That's the definition of perpendicular lines, right? Okay. If we think about angle B and angle E, and we look at our picture, they're already drawn in for us. Could I write that triangle ABC and triangle DEC are right triangles? Does that make sense? Definition of right triangles. Just misspell so I can fit it all in that line. So now, and we already wrote that AC was congruent to CD, right? AC is congruent to CD. What is AC for this triangle here on the left? Hypotenuse. What is CD for the triangle on the right? Hypotenuse. Okay. Is AB and DE, are they respectively other legs?
Yes.
So those two triangles congruent?
Yes.
So triangle ABC is congruent to triangle DEC by hypotenuse leg, right? Okay. Now, what I'm trying to tell you guys, what I'm trying to show you, is that some authors might not 100% require this. Because what they're saying when they don't require it is that pretty much every third grader knows that if I've got a right angle in a triangle, it's a right triangle, right? They're saying it's so obvious that we don't need to write that, okay? But my worry is that maybe the writer or the grader of the intercourse exam doesn't think it's that obvious. Okay? When they write the rubric for how you are supposed to answer this. Somebody earlier in the course, okay, or period, I guess, I think it was fourth period, fifth period, said, can I write in, at this stage, once I say angle B and angle E are right angles, can I write angle B is congruent to angle E? And they said because all right angles are congruent. Can they write that?
Yes.
Yes. It's true, right? Now, was it necessary? No. Okay, it's true. There's nothing wrong with doing it. And I told you that for the most part, when you see two angles that are right angles, right, that they're congruent. So there's absolutely nothing wrong with that. But in the event of using hypotenuse leg, the congruencies that are necessary for a hypotenuse leg are a hypotenuse and a leg. We don't need any angles congruent, right? So that's why it may or may not be useful to write that. Okay? And that goes to show that when you're doing a proof, as long as you have a true statement, there's nothing wrong with putting it in. For instance, if I wanted to say BC is congruent to BC, is that true for my picture?
Yes.
Yeah, but it doesn't lead me anywhere, right? It doesn't help them. Our proofs right now are kind of outlines. If I would have written it that way with angle B congruent to angle E, and then I get done with that and I say, okay, did that really impact the proof? I say no, I cut it out, and in my final draft, I don't put it in there. Does that make sense?
Yes.
Okay. So that's how you're going to use hypotenuse leg in some of the questions in your homework this evening. Also, I've added